Yusuf's back! Yes! Oh, that's good. Yusuf, you feature in the quiz at the end. Oh, Yusuf just dropping in that they're in Morocco at the moment. Right, here we go. It is I, Lara, and you are the Science Alliance. Welcome. It's the last lesson in thinking scientifically. We're doing graphs. I've got a great example of why graphs are important because I had a real life experience where I needed graphs earlier this summer. When does it happen? Okay, so obviously I teach free lessons online. I suddenly realised that there was a lot of information that I needed from my audience in order to kind of do a good job. So here are the questions that I asked my audience. Oh look, it's Freya, hello. Over the summer, this is a true story, I asked my followers these questions on Facebook to help me improve my services. I said, what is your supporter status? So most people who support me on Ko-fi, but some people support me on Patreon, which is the old system. I wanted to know if people had supported in the past, or the option was to say that you don't support me with money. Like maybe you support me with like smiley faces and very nice messages. And the other question I asked was, what times work best for you for the lessons? Obviously very important for me to know this. And I put loads of options like Monday morning, Monday afternoon, Monday evening, Tuesday morning, Tuesday afternoon, etc, etc, etc. So those are the questions that I asked. And here are the results. Are you ready? Results for the first question. There we go. This is not all the results because I couldn't be bothered to copy and paste them all, but there we go. I support on Ko-fi, I've supported in the past, never supported monetarily, blah, blah, blah. How useful are they? What do you think? Here's the results of the second question. When is good for you? So here's the Monday morning, Monday afternoon, Monday evening, stretching all the way along at the top, and then the spreadsheet just gave me people's responses dotted around. Is it useful? It's not, is it? It's not. You know what I absolutely needed? I needed graphs. So Google Doc didn't actually give me the numbers, the results, as those spreadsheets. It gave me the results as graphs, but it used a different graph for those two questions, which I thought was interesting because it wouldn't have occurred to me, not a mathematician particularly, which graph was which to use. So I thought I will ask you which one you think's best, before you might even know anything about graphs, to see what you think. For each question, what's your supporter status and what time works best for you? Can you say which graph you would use to best show the results? A pie chart, which is like a circle with kind of bits cut into it. A bar chart, it's like a pair of axes, these lines at right angles with bars to show the amounts, or a line graph where you plot points and then you join them up together with lines. I've given you a little clue. For your supporter status, Ko-fi, Patreon, whatever, I've said I wanted to know what proportion of my audience support me. Don't ask me why pie chart and bar chart are called charts, but a line graph is called a graph. I don't know. And also, someone told me in the comments yesterday, pie charts invented by Florence Nightingale. There's a whole Lego story time in there that we can do later. Oh, guys, I'm digging your answers here. Okay, yes, shall I show you what Google said? Google Doc said, for the first question, it was a pie chart. Yeah, well done if you said that. What's your supporter status? Look how easy that is compared to just all those numbers. Isn't that beautiful? So I can instantly see that over half of the people, at least who responded, are supporting me, and I can see that quite a big chunk of them have supported before, and just over a third of them have never supported. It's just so easy. For the second one, well done if you said bar chart. Yes, I can really easily see that the evenings, Monday evening, Tuesday evening, Wednesday evening, are very low. So evenings are not a good time. And the highest one just is the mornings, but afternoons would be okay. If that had been a pie chart, it would have just been like loads and loads and loads of little bits cut out of a pie, wouldn't it? Not very useful. So bar chart was a great choice there. Thank you, Google. There are alternatives. Have to mention Wanda Diaz-Merced, who is an astronomer who listens to her data. Data just means like numbers. Very successfully. She's an astronomer, so she sort of studies like waves that are coming from space. So rather than looking at them on a graph like a lot of astronomers do. Because what is a graph? It's just a way of showing numbers, isn't it? Spotting patterns in numbers. She would maybe say that like a high number would be a high note and a low number would be a low note. So she would just hear like, just as good a way to spot patterns as graphs. But we will focus on graphs today. Pie charts are good if you want to picture percentages of things, whereas bar charts are good for showing discrete data. So discrete data, discrete numbers are like whole numbers that have a clear start and a stop. So like number of children in a class or number of cars on a road. You couldn't have like half a child, right? You can only have one child. So shoe size, I mean, you could get like 3.5, but you couldn't get a shoe size 3.17568, right? What do you do if the numbers aren't discrete? If the numbers could be any number at all? Well, let's look at an example. So here, for example, is a table of how a woman started a race, okay? So someone has started a stopwatch as the race begins. So obviously when the time said 0, she had run 0 meters. After 1 second, she had run 3 meters. After 2 seconds, she'd run 6 meters, and after 3 seconds, she'd run 9 meters. These numbers are continuous. This isn't discrete. It's continuous data, because she could have run like 1.5 meters or 2.456 meters. So a bar chart isn't going to work for us. We need, drum roll please, a line graph, which is where we get these beautiful little axes, and you need to learn how to plot points. Let's briefly do that now. I know that a lot of you are going to be at different levels. If you saw my IGCSE lesson on graphs, you're probably finding this a bit tedious, but we'll start at the beginning. These are axes. One axis, 2 axes. We've got distance going up, and we've got time going across. So we've got to plot the points on this graph, all right? So when the time was 0, the distance was 0. So that's easy. We just put a cross through 0. After 1 second, the person had gone 3 meters. So we go along until we find 1 second, and then we go up to 3 meters, and we put a cross where those lines meet. By the way, my first mistake was, if you were doing this, the crosses should be in a very, very sharp pencil, not in big pink ink. After 2 seconds, 6 meters. So we find 2 seconds, and we go up, and it says 6 meters. And then after 3 seconds, 9 meters. And conveniently, look, they form a nice straight line. A quick note that obviously in real life, points aren't always absolutely perfect. So it could quite easily be that all the points were a little bit skew whiff, as my mum would say. In that case, you would draw something called a line of best fit. So if all the crosses aren't in a perfect line, you draw a line through as many points as you can, and you want to have roughly the same amount of points on either side. So that's a line of best fit. And that would tell us the person's like average speed. We won't go into that, but just, in case you were wondering. So let's do another one, and then I'll give you some questions, right? So if you were plotting this graph, this table here, time 1, 3, 5, 7, and distance 0, 1, 2, 3, how are you going to plot that on that graph? I'll give you 5 seconds just to think about what that would look like, and then we'll go through the answer, and I'll give you some trickier questions. Oh, well done, Jessica. Yeah, so this one's a bit weird, isn't it? The time is 1 second, but the distance is still 0. So the distance is 0 along the time axis. So you have to find 1 second and then just put a cross there, okay? So maybe if this was a race, this person's just had a bit of a false start, haven't they? Like 1 second has gone by and they're still just standing at the starting line like bip-bidoo-bidoo. And then after 3 seconds, they went 1 meter. After 5 seconds, they went 2 meters. And after 7 seconds, they went 3 meters. So again, we've got a beautiful straight line graph. Okay. If you have a graph, just to note, you don't need this table. You can get all the information you need from the graph. So how far did this object travel in 5 seconds? I'll give you 5 seconds. So to work out how far this object travelled in 5 seconds, you find the 5 seconds and you follow it up until you hit the graph. And then you go along to work out where the graph is on the distance, and it's 2. So the answer, well done if you got it, is, yes, well done Kai, 2 meters. Do some proper questions now then. You've got a graph to show a car's journey, and you've got distance going up on what we call the y-axis and time going along on the x-axis. And it's just a straight diagonal line through the middle. How far did this car travel in the first 6 seconds of its journey? And how many seconds did it take to travel 4 meters? Oh yeah, good point, Olivia. Both question 1. Oops. Yeah, well done. So how far did it travel in the first 6 seconds? Well, you find the time axis, you find the 6, you go up until you hit the graph, and then you follow that line along. So it is 6 meters, well done. And how many seconds did it take to travel 4 meters? Well, it's a bit boring, isn't it? Sorry. How many seconds did it take to travel 4 meters? So you find 4 meters and you go along this time. And when you hit the graph, you go down, and it is 4 seconds. All right, do you want something a bit trickier then? Here we go. Here's a graph to show the movement of a ball rolling downhill. Again, we've just got the x-axis pointing upwards with distance, and the y-axis on the time on the x-axis. How long did it take the ball to travel 6 miles? And was the ball speeding up, slowing down, or moving at the same speed the whole time? How long did it take this ball to travel 6 miles? And was the ball speeding up, slowing down, or moving at the same speed the whole time? Okay, good. So most people have spotted what I was getting at, right? How long did it take the ball to travel 6 miles? We find the 6 miles, we go along until we hit the graph, we go down, and it's 3. Oh, what? We don't know. We can't say the answer because some fool has left the units off this graph. It could be 3 hours or days or minutes. It could be 3 weeks or 3 months. We have no idea. Was the ball speeding up, slowing down, or moving at the same speed the whole time? Well, let's have a look. After 1 second, it had travelled 2 meters. Okay, it was going, for the first second of its journey, it was going at 2 meters per second. Is that okay? That was its speed. After 2 seconds, it had gone 4 meters. So 1 second went by, it travelled 2 meters. Another second went by, and it had travelled another 2 meters. Another second went by, and it travelled another 2 meters. Just going to come up and see you because I'm missing you. If a distance time graph, a graph with distance on one axis and time on the other axis, is showing you a very straight line, it means that the thing was going at a constant speed. It wasn't getting faster or getting slower. So well done if you deduce, that was tricky, that it was going at the same speed the whole time. If the line is like steeper, then that often means that it was going faster. But I'm not going to tell you too much about that because we've got a quiz at the end. I think you might be able to work it out. Before we draw some graphs about donuts, and I get to spend more time with you because you've had a lot of PowerPoint today, here's a graph, and the person drawing this graph has made 5 mistakes. Can you spot them all? All right, and then we'll move on to like how graphs tell stories, and we'll talk about donuts. But here's a graph, not a very good graph. What have we got? We've got a y-axis pointing upwards, which is labelled meters, an x-axis pointing across, which is labelled time. The meters axis goes 1, 2, 3, 4, 5, 6, 7 with 1 square per number. The time axis goes 1, and then there's 2 spaces, 2, 3, 4, 5, 6 per square. You've got pink crosses, a blue line going through them. It fills about a quarter of the graph paper. Yeah, I think that's it. Five, 4, 3, 2, 1. Okay, let's go through it then. The first major thing is, this is one thing that teachers rant to children about. There's no title. So we don't have any clue what the graph is, do we? If there's no title, then the whole graph is rendered pretty much totally useless. Always write a title and underline it with a pencil. There's no unit on the time. Well done if you got that. Yeah, what is it? Seconds, minutes, or whatever. Again, totally useless, isn't it? Saying a number without saying a unit. And yes, on this one, there's no label on this axis. So it's something in meters, but is it the height in meters, or it could be a length, it could be how far someone jumped. You've got to label your axis. Well done if you spotted that there's a gap here. Yes, this is a scale issue. The scale isn't consistent. So it would be perfectly okay to decide that you were going to say 4 squares was 1, and then another 4 squares was 2, and another 4 squares would be 3. But you can't change the scale and be like, oh, I'll do 1 square and then 2 squares. No, because then it would change. Maybe it wouldn't be a straight line, it should be a straight line, or whatever. And the last one, which I didn't see anyone getting, there's too much wasted graph paper. You've always got to fill the graph paper. You see this constantly with like GCSE students doing practicals, that you give them a sheet of paper to draw their graph on, and then they just fill like 3 squares in the corner. No, you've got to make it as easy to read as possible. So make your graph as big as it can possibly be. Okay, right. And by the way, just FYI before I show you my face again, graphs don't always have to be straight diagonal lines. So what has happened here is, well, first of all, this is a straight line here, so we know that this thing was going at a constant speed, right? 1 second went by, the travel 2 meters, another second went by, the travel another 2 meters. So this thing's moved at 2 meters per second. But what happened here on this flat bit? Well, they've reached 4 meters and then time's gone by, but they've covered no more distance. So they just stayed still for 4 seconds. That's what that means, okay? Right. Let's move on. Let's look at how graphs tell stories. So what I'd like to do, I was very kind, if you've got the printout from my Facebook page, then I've actually drawn the axes for you. If you haven't got the printout, you just need to quickly draw a big L shape. And what I'd like you to do is to write happiness on this. This could be the y-axis, if you want to be posh, the one pointing upwards. Let's write happiness here. Wow, writing backwards and sideways. Happiness. And let's write donuts on this axis. Donuts. What I would like you to do, please, is to sketch a graph. Let's put some numbers on, actually. On the worksheet from Facebook, I didn't put any numbers on, but I do think that that will be useful. How happy do you feel, please, when you've eaten 1 donut, 2 donuts, 3 donuts, 4... I'm trying to keep my lines equally spaced. 5, I'm going to go up to 6, okay? So write numbers along the bottom. I've gone up to 6, you could do more if you like. And happiness along the side. Oh, I better draw a 0 as well. Yeah, sketch your graph for how happy you feel after eating various amounts of donuts. I've made another mistake actually. Sorry if you started. What sort of mistake have I made? What should I specify really? What's a donut without a hole? A donut. Nice. I need to say how big the donuts are, right? I do need to write a unit, don't I? If they're the delicious, really small donuts that you get fresh at the seaside, covered in cinnamon sugar, I could eat more of those. I've only gone up to 6, so I'm going to say like sort of big, normal-sized donuts. I'm not going to put a unit on happiness. What is the unit of happiness? Okay. Be careful. A lot of my GCSE students used to quickly draw a graph and then I'd talk to them and they'd be like, oh yeah, no, that's not what I meant for. So I'll give you 10 seconds and then I'll show you mine. Olivia, see, if you don't like donuts, it's up to you. You could choose something that you really like. Yeah, probably do that. Choose something that you really like. If you're gluten-free, just make them gluten-free donuts. They're imaginary donuts. They can be whatever donut you want them to be. If you want it to be a donut that tastes exactly like, I don't know, a bag of Skips, just make it that. Oh, Rowan, it needs a title. Oh. Yeah, well, it's just a sketch. Don't make me write this. How my level of happiness is affected by donuts is the title that I'm not going to write backwards. Lego. All right. Okay. Shall I show you mine? So, yeah, when I used to start some of my GCSE lessons like this, a lot of students would just do this. Like that. There's a few problems with that. Where's my... No, there it is. There's a few problems with this, isn't there? Just drawing a line like that. Pure laziness. First of all, really, the more donuts you eat, the more happy you feel forever, really? And the other thing is, like, I mean, how happy are you right now? What is your happiness level right now? You probably, unless you're very lucky, you probably don't have any donuts in front of you. Have you got 0 happiness? No, like someone said, maybe you've got Lego instead. So I'm not starting my graph at 0, okay? When my amount of donuts is 0, my happiness is not 0. I'm going to say I'm like here, like pretty standard happiness. If I ate 1 donut, I like donuts. So I would definitely be happier than I am now. So I'm going to put, I mean, quite a lot happier actually. If I ate 2 donuts, would I be more happy or less happy than after I've eaten the first donut? I think I'd be getting full. I'm gonna put across very slightly above. Don't judge me. Yeah, I think I'd be happier after 2 donuts. If I was forced to eat 3 donuts, no. I don't think so. Not if they're big donuts and not seaside donuts. I mean, if it was like really fresh, like crispy on the outside, squidgy on the inside and covered in cinnamon sugar, I wouldn't be that much less happy. But after 4, I'd be far less happy than when I started. And after 5 donuts, well, I didn't really plan for this, but actually after 5 donuts, I would be, if someone forced me to eat 5 big donuts, I would be unhappy. I would be like minus happiness. And this is what you do in proper graphs all the time. You just add a line down here and say, okay, this is minus values. So if we put a number on happiness, you know, we haven't, obviously, but if we had, then down here we'd be saying, okay, this is -1 happiness, -2 happiness, -3 happiness. So if I've been forced to eat 5 donuts, I am now very much in the minus happiness, so I'd put a line down here, and after 6, I'm blooming miserable, and and it would just go further and further down. So there we go. So drawing a line through my points. There, that is my graph of how I feel after X amount of donuts. You can only manage 1, Izzy B. Well, I want to see what your graph looks like then. So your graph might well look different to mine, but what I'm trying to show you is that if I hadn't said everything that I just said, you would be able to learn it all just by looking at this graph. If you looked at this graph, you know instantly whether I like donuts or not, whether I'm a generally happy person or not, and how many donuts I can fit into my body before I feel incredibly sick. Right, at the end, usually we do GCSE past paper questions. There aren't really any past paper questions that I could find that you didn't need to know like loads of other stuff for, so instead I've done you a fun time quiz. Someone has robbed a teacher's making boring things fun. Someone's robbed a bank. And a keen physicist, there were no cameras in the bank, but a physicist who saw what happened sketched distance time graphs of 5 people in the area. So I want you to match the movement descriptions I'm going to give you to the distance time graph to work out who committed this terrible crime. Here we go. Are you ready? So you've got distance time graphs for Olivia, Joseph, Adiba, Yusuf and Ian. And I'm going to give you a description now. So this person was waiting for a bus and then got on the bus. So they are innocent. Find the person whose distance time graphs looked like they were waiting for a bus and then they got on the bus, because you can tick them off as being innocent. If you haven't got the printout, you just write down their name. So Olivia's graph is a straight line and then it goes up at a diagonal. Joseph's graph goes up at a diagonal and then is flat. Adiba's line goes off at an angle, quite a gentle angle. Yusuf's goes off at a steepish angle but then gets really steep, and Ian's looks exactly the same as Adiba's. Right, oh, I know everyone just wants donuts now, yeah? Right, the next one, I'm not going to give you the answer until the end. So this next person was jogging past the bank and then stopped to see what was happening. So they are also innocent. Which distance time graphs looks like a person who was jogging and then they stopped and they stayed still to see what was happening? So they were moving and then time went by, but they didn't travel any distance. Well spotted, Izzy B. Right, next one. This person was walking past the bank. They are also innocent. Be very careful. Izzy B has spotted something that you need to spot to get this right. Which one of these people was just strolling slowly past the bank and is innocent? 5, 4, you have to notice something about the graphs. 3, because you might think that it could be 2 people, but it can only be 1 person. 2, 1, and the last one. Well done, Roman, for noticing. This person ran out of the bank with the cash and jumped into a moving car. Who was that? Which person ran out of the bank with the cash and jumped into a moving car? 5, 4, 3, 2, 1. Well done, Noah. Right, let's go through the answers then, shall we? Who is the guilty party? The first one, this person was waiting for a bus and then they got on a bus. That was Olivia. Look, she waited for a bus. Time went by, she didn't travel any distance, and eventually she got on the bus, so she started moving. Time went by and she moved. Yep, so Olivia is innocent, well done. This person was jogging past the bank and then they stopped. That must be Joseph, yeah, because he's got this moving and then his line is flat. So time goes by, but it doesn't travel any distance. So well done, you said that Joseph was innocent. Oh, this one was so hard. They were walking past the bank, they're innocent. Well, you might think that both Ian and Adiba looked like they were just travelling at a constant speed. But look, some people noticed that Olivia's axes were flipped. So it was Ian that was innocent. Let's have a quick look at what is happening here. So on Adiba's graph, what's she doing? So this is time going upwards and this is distance going across. So we've got this very shallow line. But look, after just, let's say that 1 square is 1 second. After like less than half a second, what distance has she travelled? If we go along for half a second, she travelled like absolutely miles. Is that okay? Can you see that? So when time is very low, distance is very, very big. So Adiba was actually like in a helicopter flying over the scene. Whereas Ian here, look, not much time has gone by and he like here, say, 1, 2, 3, 4, 5 seconds has gone by, let's say, but he's hardly travelled any distance at all. Is that okay? Here, lots of time has gone by, not much distance. So Ian was going slowly. And the person who was guilty was Yusuf. Well done if you got that. So he's travelling at a constant speed, and then he's suddenly travelling at a much higher constant speed, because not much time goes by, but suddenly he's travelled more distance. Yusuf, it was written all over him from the start. Well done if you got that. Yeah, Yusuf, it was you. Exactly. No wonder you've escaped to Morocco. Right, you lot. That's fantastic. Thank you so much for coming. That is the end of the show. I'm doing it as like a special offer at the moment, so I should tell you about it, although most of you know. If the only way I can teach these lessons is because enough people are supporting me with £5 or £6 a month. It's just this amazing business model where I do everything for free and the printouts are free. And if you want to, you can pay me £5 or £6 a month, and enough people are doing it. There is an incentive because I send you Theatre of Science magazine. So adults, if you go to my blue button on my home page that says sign up and click it, it'll take you to this website where you can sign up for Theatre of Science magazine. When you sign up, you always get the latest issue. Are you going to do drama? Nice, Rowan, bye. You always get the latest issue of Theatre of Science magazine. And this is the latest issue. It just arrived. It's on time. It's got a beautiful sundial craft in it. It's got a beautiful comic that my husband illustrated about a woman that sold time. It's got all the information you need to know about slow worms. They're so cool. It's got an article about Einstein's theory of relativity. It's got a beautiful quiz. So this is the latest issue that you'll get if you sign up now. But it's only just the latest issue. And the last latest issue was like the bumper issue on seeds, which, you know, it was the bumper issue, so it was bigger and you got lots of little free gifts, and I have got some left. So I'm saying if you sign up today or tomorrow, if you're watching this in recorded time, it's Wednesday or Thursday, then I'll send you the previous issue, because it's really good. And just a bit bigger. The new issue is very good as well, but it's like a standard issue. So yeah, if you sign up today or tomorrow, I'll send you this one, and then you'll get the next issue quite soon after. People who do support me, generally, there is an envelope with your name on it in my living room, and I'm going to try and get them posted today. I'll see how I go. Right, thank you so much everyone who's supporting me. Thank you so much for just coming and chatting and making brilliant comments. The seeds did not grow. Oh no, Betty! When I have got some left. If I see your envelope, Betty, if you want to message me and tell me what your coffee name is, then if I see your envelope, I'll try and stick some more in for you. But I can't promise anything because there's 700 envelopes, but I do get to like see them all as I'm packing them. So if I see yours, I'll be like, oh yeah. So let me know. All right, yeah. So this one was the last one before half term. I'm taking a week's break for half term to parent my children. And then we'll start again after half term with a whole new topic. So I'll be posting in my Facebook group to see if anyone's got any suggestions for topics. Adults mainly talking to you there. Have a think about what you would like to learn next. Bye, Norm. Bye, everyone. I'm going to go and plan a story time on fear for Halloween. Bye, Natalie and everyone. Thanks so much for coming.